Hello and welcome to the next project wherein we will integrate ROS with Arduino. Now, Arduino is a very popular microcontroller, and it has changed the way in which open source and especially robotics has come up in the last 5 years. It has made robotics really accessible for everybody around this world. So it is very important that we see a concrete implementation of ROS with Arduino. This has also come as a request from multiple students. So let's get cracking on a simple way and an interface between ROS and Arduino. Now, one thing which came to my mind when I was shooting for this course is that the thing that the ROS community gave and the message which is there is that not to reinvent the wheel and to be smart while progressing towards robotics. Now, a lot of the interface, especially with Arduino and the commonly used sensors, are already there as drivers. So we need not write it from the scratch. Okay. So here is one cartoon illustration of the primitive age of humankind, wherein there is a dude saying that, hey, why don't you try this wheel? It's round and probably does the job. But the core team is very busy with square wheels and they say no thanks. So we need not be like that team, but we should try to reinvent. We should try to avoid reinventing the wheel. Now, the interface or how we use ROS with Arduino is through a protocol, and that protocol is called ROS serial. Okay, so number one concept is that we'll use a protocol, and that protocol is ROS serial. Now, as I said, that we need not reinvent the wheel, especially if you are trying to interface commonly used microcontrollers as Teensy, XB, Arduino, or even STM32 boards. Most of the stuff are already written, but yeah, if you need to use certain boards which are not already there in the ROS serial, then you need to write your own interface between ROS and the hardware. Okay, but as far as Arduino is concerned, we'll go with ROS serial. Now, within ROS serial, we have ROS serial client, which is the client side implementation, and it is designed for microcontrollers to run with ROS, and it is based on C++. And for Arduino specifically, we have the package which is ROS serial Arduino, which I was saying. Now, beyond this, we also have two server implementation of ROS serial, which are termed as interfaces in the ROS wiki. Now the Python implementation is called ROS serial Python, and this works quite well. There is also a C++ one, which is a bit hard to use, but it is recommended for high performance application and robotics. So in this entire project and section, we'll be using Python, and especially we'll be using the server implementation of Python using ROS serial Python. Now finally, in your Arduino board, the base library, which is the dependency which has to be installed for all the tools and client libraries, and also for generating the messages and services which are understood by ROS. The library which we need to install is called roslib. And as you can see that if you go to your examples libraries, if you have used Arduino IDE, you would understand and you would see this roslib library which needs to be installed, and within this you will have some example codes. Okay, so this is the base dependency that needs to be installed. Now I understand that this was too much of information, and it seems complicated at the first go. So long story short, we need to use the ROS lib in Arduino, because that has the base packages, that also has the example codes which we'll be using mostly for this section, and we'll be using the Python implementation of the server, which is the ROS serial Python, and not the C++ version. Okay, now the architecture looks something like this. Now if you have to interface Arduino on your right to a laptop which is running your ROS, first of all you connect it with the USB, so that the serial communication is placed, and after that obviously you run the ROS core, which is the ROS master node, and then you can have your laptop. One way of doing it is You can have the laptop as your publisher, and and you can have your Arduino as a subscriber. And as I said, you can have the ROS serial underscore Arduino, which is the Arduino codes for ROS serial. And you can use geometry message or sensor message like the twist message or empty message, which we saw in the previous state, to not only read and write, subscribe and publish from Arduino, but also control sensors like a servo and an ultrasonic sensor. And finally, you can use the RQT graph for visualization of what has happened in terms of integration with Arduino. So what is key to understand that we'd be using the USB for the serial messages, and then the ROS lib base library has to be installed, and the protocol would be ROS serial underscore Arduino, which is a subset of ROS serial. And then we use the sensor message and the geometry message using twist, range, etc., as we did in the previous robots, to control the sensors, a servo, or even a DC motor. So hope this was helpful, and I'll catch up with you as we see in the next tutorial how can we use Arduino both as a publisher and as a subscriber. I'll catch up with you in the next video.